Okay, so thanks for that introduction, Tim, and thanks everybody for inviting me to be here. It's a real pleasure to speak to you all, and I think it's great that you're having this SARE-sponsored training here at the Horticulture Expo. I'm going to be talking a lot about grafting of tomatoes. So raise your hand if you've ever heard of tomato grafting prior to this session. Cool. Have you ever tried tomato grafting? Do you think it's insane to graft a tomato? Go ahead and raise your hand. It's all right. I sort of thought that too when I started this project. I just finished my PhD out at North Carolina State University, and I actually did pretty much the entire 6 years of work on some form or shape of tomato grafting work. So I've been doing this for a little while, and over the past 5 years, it's become less common that people think I'm insane for trying to do this, and we're starting to generate some data that really shows that grafting is beneficial for a lot of growers. Especially here in the southeast when you're facing disease problems, and especially for growers that utilize heirloom cultivars or high tunnel production. You see this high tunnel here. One of the things, I'm not going to be talking about economics too much today, but we have done some economics work. But as you're thinking about grafting for tomato production, think about the per plant revenue that each individual plant generates. So if you have, 20 acres of Biltmores sitting out in eastern Tennessee, you pick them for 3 or 4 weeks, and then you're done. You may get 15 to 20 pounds of fruit. You may sell them for 25 cents a pound, and so now you're looking at $4 or $5 per plant, right? Well, we've estimated that it costs about 50 cents to $1 to produce a grafted transplant. So one of the things that's important is thinking about that revenue per plant. So let's look at an organic heirloom grower in a high tunnel. These guys grow plants early. They harvest as long as they can. They can get up to 30 to 35 pounds of fruit per plant, and they're selling them at a farmer's market for $3 a pound, if not more. So now you're talking about $100, $110, $120 per plant that you're generating. So in that case, 50 cents to $1 is completely negligible. And of course, there's lots of in-betweens. And that's where we're doing the research now, is trying to figure out where that middle point is when this does become an economically feasible technology. As Tim mentioned, and I mentioned, I did a lot of this work at NC State, and I actually just moved to Kansas State. I actually just started there December 1st, and so I don't really have anything on the web yet there, but if you're looking for more materials, there's a bunch of stuff on my old NC State website. If you just Google my name, you Google tomato grafting, you will find it. There's some extension publications there. There's field day handouts. There's informational handouts. This handout that's coming around with the names of the rootstocks is posted there as well. So I really encourage you to go to that site if you need more information. I do want to make sure I give credit where it's due. Again, most of this work was done at North Carolina State University. I worked with my advisors, Dr. Frank Lowe's in the Department of Plant Pathology, but we also worked really closely with Mary Pete in the Department of Horticulture and her graduate student, Suzanne O'Connell. So I just want to introduce those folks to the group. Again, this is not a one-man show. Okay, so the first reports of vegetable grafting really came out in the turn of the 20th century, and mostly out of Asia. In Korea, Japan, some of these Asian countries, they've been carrying out grafting for a long time. The first vegetable crops to be grafted were actually melons, and they grafted them onto gourd rootstocks in order to manage fusarium wilt. And they still graft melons for that same reason. For tomatoes, this occurred, they started grafting tomatoes more in the 1950s and 60s, mainly to manage a disease known as bacterial wilt. But these have become really popular, of course, in Japan and Korea, and they've really taken over tunnel and greenhouse production over there, both in Asia, also around regions of the Mediterranean, countries like Spain, Italy, Morocco. They're carrying out this grafting thing to a very wide scale. Of course, the top part of the plant is the scion, the bottom part of the plant is the rootstock, and the graft union is what holds everything together. So here you can see a couple of numbers in terms of some of the production in Asia. And again, this is just done very wide scale. And the only reason I wanted to show this picture was to just show you, the commercial scale of these tomato grafting or vegetable grafting propagation systems. Here, this is actually what's going to become grafted watermelons. These are grafted tomatoes, and these are grafted peppers. So when we try and figure out why we want to graft a tomato plant. It's not really just because we want to torture this poor thing during its seedling life. We really want to get a benefit out of it. And I think a lot of people get tricked up with this idea. We always say grafting, grafting, grafting. The hot word of the day is grafting. But we need to change our focus. The hot word of the day is actually rootstock. The rootstock is what's giving you the benefit. So let's think about what benefits rootstocks might give us. Well, obviously, the root system is an entry point for pathogens, other pests that may get into the plant and cause things like vascular wilt diseases and other issues like this. It's also, of course, important for water and nutrient uptake. And we found that a lot of these rootstocks not only are very resistant to disease, but they're also incredibly vigorous too. Some of them almost too much so. The other thing that I just want to point out is keep in mind that these rootstocks are not magic. And if you have foliar pathogens that are attacking the top part of the plant, you're probably not going to get a lot of benefit except for maybe some indirect benefit from vigor. And I get a lot of questions from growers about this. They hear all these disease names and they don't know which is which. Early blight and late blight are both foliar attacking pathogens. Tomato spotted wilt virus enters the plant through the foliage tissue. So in those cases, grafting is really not going to help you very much. If we could find an easy solution for early blight, I wouldn't probably be working for the university right now. So while I was in North Carolina, we did a whole bunch of field trials, many of them on farm, many of them in research stations, a bunch of them organic, a bunch of them conventional, some with heirlooms, some of them with hybrids. And so we got a lot of experience just trying to figure out what some of these different rootstocks are and also trying to see how they integrate into different systems. And here's some of the diseases we were able to work with. North Carolina is blessed in that as a plant pathologist, we have lots and lots of diseases we're trying to manage all the time. And we found rootstocks that can manage really each one of these diseases. And I don't have time today to go through all the diagnosis part of how do you identify a soil-borne disease. But as extension agents, you folks should know that this diagnosis step is really one of the most crucial parts of this whole process. Because keep in mind that most rootstocks are not resistant to every single disease. And so the first thing you have to do is figure out what your problem is before you can actually recommend a rootstock for it. So again, as a plant pathologist, for me, the primary reason to implement this grafting thing is to manage soil-borne diseases and root diseases. And we've got a whole list of diseases up here, as well as rootstocks that we've worked with. And so, and this is actually the chart that's on that handout. And so we can go to growers and say, these are some of the rootstocks we've worked with and what we've seen. Now, in most cases, these rootstocks are known as interspecific hybrids. So what that means, it's actually a wild tomato crossed with a domesticated species. And that's where you generally get a lot of vigor component because these wild tomatoes are, they're just monsters, to be honest with you. And they grow much faster, they have bigger root systems, and you get a lot of vigor that way. Probably the two most popular rootstocks right now in the U.S. are Beaufort and Maxfort. Both of these are available at Johnny's, Hydro Gardens, Seedway. Actually, Seedway doesn't have the derider lines. They have some other ones. But Beaufort and Maxfort are the easiest to find. Now, one of the things that's also important, I think, as agents you should realize is that the resistance characteristics of these rootstocks are not always any different than our typical hybrids. So if you open up your seed catalog and you see Better Boy VFN, that V and that F and that N stand for what's known as major resistance genes to resist verticillium, fusarium, and nematodes. Now what the breeders have done in Europe, and that's where most of these rootstock lines are coming from, is Europe and Asia, is they've actually been able to take those major resistance genes and dump them into these rootstocks. So you get a whole slew of resistance genes against some of these common soil-borne disease problems. But in most cases, and these are the ones I've highlighted here, these are the ones where we have major resistance genes available. These are functionally the exact same thing as grafting onto your Better Boy VFN. Because if your major problem is Fusarium wilt race 1, you don't have to go buy an expensive rootstock seed to manage that issue. Because it has the exact same resistance in it that maybe a Better Boy does, or one of these other hybrids. Something I will point out along those same lines, we've also found that even though they carry the major resistance gene for root knot nematode, we've got a couple of rootstocks that are becoming problem children, so to speak. So pretty much all the rootstocks carry the MI gene, or what you would see as the N, sometimes it's listed as the N gene in the seed catalogs, and that's for root knot nematodes. But two of them in particular, Beaufort and Maxifort, they really don't show super high resistance to this. They actually show some intermediate resistance and some tolerance. You still get good yield, but the nematodes can still reproduce on that root system. And that can be a real problem for growers that are following tomato with a real susceptible cash crop like lettuce or cucumber. And so it's important to keep that in mind. If you have a real nematode problem, you probably want to go with something like a Big Power. That's probably the best rootstock we've found for nematode resistance. The other thing is, because of this, and we suspect that it's because it's an interspecific hybrid that it's having these problems with the MI gene, we're going to have to be cautious as we make recommendations for root knot nematodes. In our trials, the only rootstock that we've seen that really does extremely well against nematodes is Big Power. We also saw that Beaufort and Maxifort do intermediately well. We really don't have good data on the rest of them. And so the truth of the matter is probably this chart needs to be sliced in half, because I'm sort of questioning, whether or not these seed companies, they say it has MI gene, but it may not be working correctly. I did want to talk specifically about a couple of diseases, and first is southern bacterial wilt. Now, raise your hand if you've ever seen or heard of bacterial wilt. Quite a few, good. This is a huge problem in North Carolina on the eastern part of the state. It's an old problem there. But in the last 10 to 15 years, we saw this pathogen move out to the mountains in North Carolina. And I've talked to growers and other folks from eastern Tennessee, and I know it's also a big problem in eastern Tennessee as well. Bacterial wilt is caused by this bacterium known as Ralstonia solanacearum. And this is this tiny little bacteria that lives in the soil, and it's incredibly persistent. It lives in the soil for a really long time. And what's amazing about it is just how devastating this disease is. It moves into the root system. It colonizes the vascular tissue or the plumbing tissue of the plant. And then about the time that it really needs that water, when you first got the good fruit load, then they just completely wilt. And you can see them, I mean, it almost happens overnight. You go out and you see plants that are just completely collapsed like this. So we actually, over the course of the 6 years, we did a lot of work looking at this pathogen. Because one of the things that's historically very challenging about this particular disease is resistance is strain specific and may not be durable over geographic locations. So what that means is these are little tiny bacterias, and there's so much diversity in the population of the bacteria that it's really hard to recommend a rootstock, because some rootstocks are resistant to certain strains, some rootstocks are resistant to other strains. If you talk to the folks from the AVRDC, they've been running tests on this exact same thing for 20 or 30 years. And so if you know a grower that has bacterial wilt, wants to implement grafting, I would highly suggest trying to get a small-scale sort of on-farm research trial to look at a couple of the different rootstocks. Because we found that, well, you can't see it here, but RST04105 is one that's recommended typically. It did really well for us on the eastern part of the state, but when we put it out west in the mountains, it did horribly. And so, just because it says it's resistant, don't necessarily trust that. The other thing that's not listed in your handout, and you may want to write this down, is there's a line called RST04106, and that is available from Seedway. And there's a fella up in Virginia and some other folks down in Florida that have been working with that line quite a bit. And we did a little bit of work with it last year. It seems to hold up better than the 105 does. And it's also a little bit easier to graft. It's more uniform of a plant. So you may want to think about trying that one out as well. Another disease I thought I would mention is this disease called southern blight. And southern blight is caused by a fungal plant pathogen that lives in the soil, Sclerotium ralsii. And Sclerotium ralsii is very difficult to manage because it's really common in soils. It loves organic matter. It loves organic farms. If you use cover cropping and no-till, you have probably seen this disease before, because it can metabolize all kinds of carbon in the soil, and so it's able to persist in soils for a long time in that way. Now, diagnostically speaking, this is an easy one to identify. You get this nice white mold right around the crown of the plant, right at the base of the soil. And actually what that pathogen does is it lives on the top of the soil, and it just grows along the top of the soil, injects its oxalic acid into the stem of that plant, kills that tissue, girdles it, and you just get complete and total wilt. It just collapses, right? And so this is another one that's really hard on yields, like bacterial wilt. Now, there's actually no known resistance to this disease in any commercial cultivars, which is actually the same with bacterial wilt as well. And we were actually pleasantly surprised to find a few years ago that these interspecific hybrids have really good resistance to this disease. And we're trying to get some grant money to figure out why that is. But consistently over locations and over years, we're seeing a lot of our rootstocks do really well against this disease, particularly Beaufort and Maxifort seem to maintain really good resistance to this one. Okay, so I'm going to show a little bit of data today. I'm going to talk real quickly about a trial that I helped with up in Pennsylvania. And this fellow is named Steve Groff. And Steve is a very well-known grower in the Northeast. Probably some of you have heard of him or read about him or seen him give a talk down here. He's well known for his work with no-till vegetable systems. Also he's kind of the cover cropping guru of the whole Northeast. He actually runs a seed company where he produces forage radishes for cover crops. And so he's very progressive. And one of the things that he's done is he implemented these high tunnels. He has 2 acres of multi-bay high tunnels. Now I mentioned high tunnels earlier and how important grafting is in high tunnel production systems worldwide. And one of the reasons for this is because once people put up high tunnels, they either want to shorten their rotations or eliminate them altogether. And that's what Steve did. As progressive as he is with his cover cropping systems, he doesn't want to rotate in those tunnels because they're just worth too much money, right? And so he's been growing tomatoes in parts of these tunnels for almost 10 years consecutively. And he saw me give a talk up in Pennsylvania like in 2007, and we've done some work with verticillium wilt. And so he tracked me down and said, hey, let's do some on-farm work. And we were actually able to do trials there 2007, 2008, 2009. I think we were able to come up with some really interesting results. So verticillium wilt, this is another fungal plant pathogen. And it's very different than bacterial wilt or southern blight because this is a sort of a subtle pathogen. It doesn't come in and kill the plant. It grows into the vascular tissue very slowly. It's a slow-growing pathogen, and it slowly kind of strangles the plant over the course of the year. And so a lot of times at the end of the year, you start seeing these classic diagnostic symptoms, the V-shaped lesions down in the lower leaves, and slowly they might move up the plant. But this disease has been managed with fumigation for a long time. For one, because it's so subtle, and also just because of the biology of the pathogen. And what I mean by that is, if we open your seed catalog again, you got a Better Boy VFN. Well, the V stands for the VD gene, or resistance to verticillium wilt race 1. Now what happened was, however many years ago, the breeders released that V gene, it started getting put out into all these different areas, and very quickly, just due to the biology of the pathogen, it was able to overcome this resistance. So you might have seen in that chart, verticillium race 1, they all have a big R, right? But truth be told, there's really no tomato that's resistant to race 2. And race 2 is what's most prevalent out there. And if you put a tomato with race 1 resistance, pretty soon you will have race 2 in your field. And in western North Carolina, race 2 is everywhere. I imagine it's the same here in eastern Tennessee. I know it's also true up in Pennsylvania where this grower is. So in this case, we knew we didn't have resistance to the pathogen. And so we sort of took a different approach. We knew these rootstocks were super vigorous. And so what we said is, let's try one of our most vigorous rootstocks and see if it can just functionally compensate for the penalty that the pathogen does to the plant. In other words, can these rootstocks tolerate colonization by the pathogen but still maintain high yields? The other thing is Steve is not an organic grower, and so he has been using fumigation to manage this disease prior. And so he really wanted to find out, is the implementation of grafting going to be an alternative or an additive in terms of compared to fumigation? And so these were basically the objectives. can we utilize this vigorous rootstock? In this case, we use Maxifort because it's probably the most vigorous one that we've worked with. And then how does grafting fit in with fumigation? But then we also had a great opportunity here, being that it was on farm. He was also far enough away that I was really trying to figure out some way for somebody to produce grafted transplants up there. And so we did some economic work, both looking at plant spacing and transplant costs. Now the plant spacing becomes important because, again, we're adding 50 cents to $1 to every plant you put into the field. So if you can reduce the cost, the transplant cost, by stretching it out to 24 inches instead of 18, then this is going to be an important finding for a more expensive transplant. So we did find that indeed, just like we saw in North Carolina, these grafted plants would still maintain colonization. We still saw symptoms of verticillium on the grafted plants, and that did not change between grafted and non-grafted. But what did change was the yield, and that's what this graph shows. So what you can see here is, first of all, fumigation is very effective at reducing the yield penalties caused by Verticillium dahliae. You saw we had about a 25% increase in yield just by fumigation alone. You can also see that the ones grafted on Maxifort and non-fumigated had significantly more yield than the non-grafted and fumigated ones. In fact, it was, again, another about 20% increase in yield. What was really interesting to me as a plant pathologist is we really saw no difference, or very little difference, between our fumigated and non-fumigated plots when we use the grafted plants. So what this indicates to me is that we're showing some type of a tolerance mechanism with these rootstocks. Here you can see some of the plant spacing data. And basically, Steve grows his tomatoes typically at 18 inches in the row. I think that's pretty common for determinate reds. And basically what you can see is that the Maxiforts were not only produce a higher yield at 18 inches, but also at 24 inches as well. You got more per acre yield than you did the non-grafted ones at 18. Right? So we start talking economically, that becomes very important. The other thing, and I'm not sure I would recommend a 36-inch spacing, but we just kind of wanted to do it for proof of concept, we actually cut the number of grafted plants in half, and we had the same yield as the 18-inch and non-grafted ones. I think, truth be told, we probably need to do some more work. 36 inches is a lot of space between a tomato plant. I probably wouldn't go any wider than 30, and that's still probably pushing it. But again, you can really see that these are very vigorous plants. So, when we look at the economics, we were basically able to show that although it was only by a few $100, the 24-inch spacing really provides the best net returns of grafting compared to the 18 inches. In 2009, actually by the time 2009 hit, Steve had actually changed his entire high tunnel over to all grafted plants and all at 24-inch spacing. So you can see the benefits of on-farm research right here. But you can see these numbers. This is per acre of net returns of grafting. And I asked Steve when we put these numbers together, I said, is this really accurate? You're talking about adding $13,000 per acre. And he said, absolutely. So he's very excited. Steve writes me great letters of recommendations. He loves the work that we were able to do. And he's continuing to use grafting at his farm. Okay, so we're going to move from the disease resistance part to the water and nutrient uptake and nutrient assimilation part. We will, by the way, I should have said this before, in the last half of the presentation, I am going to tell you how to actually graft a tomato plant. So don't worry, we're going to get to that sooner or later. So this bit of work was done at the Center for Environmental Farming Systems, which is in central eastern North Carolina. And this is sort of our research station dedicated to sustainable agriculture. Since this is a SARE track, I will say it was funded by a Southern Region SARE Research and Education Grant. And so we were looking at the use of grafting in organic high tunnel and open field production systems for heirloom tomatoes. We used Cherokee Purple in this case. And we basically grew the grafted and non-grafted plants inside the tunnel and outside the tunnel, and then looked at the benefit within each system. We also did some fertility work as well, looking at the grafted and non-grafted plants at different fertility rates, and some other stuff too, which I probably won't talk about today. And basically, we got some money to build these things, and we basically had two 30 by 96 foot high tunnels that we put up. We used organic practices. You can see the compost being applied, so on and so forth. Within the high tunnels, we used what we're calling a twin leader, and this is sort of a modification of the European string trellis system. So in a lot of greenhouses in North Carolina, people will actually drop a string from the ceiling and train it down to one sucker where that sucker chases a string up to the ceiling. And so one of the things that we did was we didn't really like the single leader, so we actually pinched the plants and formed two leaders to come out and use that system inside the tunnel. Outside the tunnel, we use just a traditional stake and weave system. So you can see here some of, and this is actually Susie's data from her master's thesis, some of the nutrient data. And basically, I'm not going to go through each nutrient one by one, but these grafted plants do a great job of picking up more nutrients in the soil and moving them up into the plant. We had significant results, significant effects on all the major macronutrients in that the grafted plants picked up more nutrients. The other thing that's interesting, and this is another thing that's driving this grafting thing in the Mediterranean, our grafted plants also picked up less sodium. And for those of you that worked in high tunnels, salinity can be a problem in high tunnels if you're cropping these things over and over and over and over. And there's actually been a lot of work done over in the Mediterranean region that shows a lot of these rootstocks are tolerant of saline soils. And we saw, evidence to support that in our study as well. When it comes to yield, we saw pretty tremendous yield benefits of grafting with Cherokee Purple Scion. And again, I should reiterate, this is in a non-disease situation. There's no disease, no soil-borne disease in this field or high tunnel. And you can see, 42% yield increase is pretty good. 2007, Maxifort sort of came out on top, although it was statistically similar to Beaufort, and both were statistically more than the non-grafted. In 2008, we saw that trend flip-flop a little bit in that the Beaufort were actually on top numerically, but again, statistically, they were the same and different than the non-grafted ones. But again, if you can increase your yields by 35 to 40% with these organic heirloom tomatoes, you're talking big bucks. Okay, so in terms of the benefits, again, grafting really just provides a great way and a site-specific tool to manage diseases and soil-borne diseases specifically. And one of the things I really try and harp on a lot when we talk about this is disease diagnosis and rootstock selection are really the most important steps to implementing this technology successfully. In a world where we had a broad spectrum fumigant like methyl bromide, we could just say, oh, you have disease, use methyl bromide. But in the world of rootstocks, we have to figure out what that disease is. And so this is going to be a challenge, I think, for those of us working in extension because we gotta really do a good job of disease diagnosis in the field, or else we're going to be recommending the wrong rootstocks. Again, these rootstocks seem to add a lot of vigor and nutrient uptake. And so one of the things that we've done, and I haven't gotten a chance to talk about it too much today, is look at different ways to manage these things culturally, just to manage that vigor and to get a better bang for your buck out of that vigor. One of the ways we did that was with that twin leader system. We also always do a lot of pruning and de-leafing to keep the plants in the reproductive mode. Some of these rootstocks are so vigorous that they want to make the plant more vegetative. And so don't be afraid, to do a bunch of pruning, de-leafing, maybe cut back on the fertility, etc. Okay, so now we're going to get to the fun part, which is how do you actually graft a tomato plant? Now that you're all convinced, right? So we have been grafting at NC State for many, many years. I'll be grafting at Kansas State here pretty soon for many years to come as well. And, we typically do this. We've done it in a number of systems, some in very high-tech greenhouses and growth chambers, but also a lot in very low-tech systems as well. If you would like a step-by-step instruction manual for this extension publication is available on my website as well as a number of others. And it's basically North Carolina Cooperative Extension Service published it. It's called AG 675. And there's a very, very nice step-by-step, this is how you graft a tomato plant. So it's out there if you need it. Now, AG675. Okay, so now that you know where the step-by-step process is, I'm here to tell you right now that nothing in life is as simple as a step-by-step cookbook recipe, right? And you folks know this, I'm sure. We're talking about a biological organism. These plants grow at different rates in different greenhouses and different soils at different temperatures. And so all of this stuff we have to be a little bit flexible with. And this is something that when I talk with growers, they get frustrated with me because they read on these publications, you must plant your rootstock 5 days ahead of your scion, right? And sometimes the rootstocks grow faster than the scion. Sometimes the scion grow faster than the rootstocks. And so we have to be able to be a little bit flexible in that way in order to make the system work. There are some general principles that I like to really drive home when I'm giving these workshops. One, if we can't figure out a way to do this and scale it up to commercial production, it's not going to be very helpful to us. Any home gardener can produce 50 grafted transplants, but we need to be thinking in terms of 50,000, 5 million, 50 million. Uniformity is probably the biggest, most important step in this process, because at some point you're going to have to take a rootstock and a scion and get them to match up on their stems. And again, this is happening when the plant is very small and is growing very quickly. And so you need a nice uniform crop both between the rootstock and the scion so those stems match up, but you also want a good uniform crop within each one of those, right? Because you don't want to be dealing with a bunch of variability when it comes time to actually carry out the grafting. Water stress. You have never learned how to deal with water stress in a plant until you've cut its root system off of it and tried to get it to survive. And we'll talk about some of the principles of how water moves through the plant. And this becomes really important when you're trying to manage that healing chamber. Healing chamber management is probably the most difficult step in this whole process. I keep saying that. This is the most important, the most difficult. One of these days we'll figure out which one's the hardest. Sanitation is also crucial. You keep in mind, after you graft this plant, you're going to have to move it into this healing chamber where we raise the humidity and cut out the light. And these are perfect conditions for a disease epidemic to break out. And so you want to make sure your plants are very clean. I typically recommend, a lot of organic growers like to mix compost into their substrate. I typically recommend to not do that until after you've grafted them. You can mix the compost in later when you pot them up, because you really don't want to introduce any foreign organisms into that healing chamber that could cause a disease outbreak. One quick slide on costs. We have published some economic work looking at the cost of propagated grafted transplants. And I think a lot of people get all tripped up on the slicing and dicing. What's the labor like to actually carry out the grafting? Well, the labor is about 14 to 24% of the added cost. The most important factor in adding cost is actually seed costs. These rootstocks, again, are interspecific hybrids. They've been developed in Europe and Asia, most of them for hydroponic greenhouse production. And so most of these rootstocks are in the range of 15 to 25 cents a seed, which can be a major hitch for a lot of folks, especially if you're used to heirlooms, which are, a tenth of a cent a seed. The other thing is indirect costs. And basically what I mean by this is keep in mind you've got a rootstock crop and a scion crop prior to grafting. And that takes twice as much propane, takes twice as much bench space, takes twice as much plastic and soil prior to the grafting. And so when you're designing a system for producing these grafted transplants, you want to think about ways to keep that cost down, just like you want to think about ways to keep your labor down and the cost of the rootstock seed down. So we typically carry out what's known as the tube grafting technique. And this is among the cucurbit crops, nobody's really decided what the best way to do it is. With tomato, tube grafting is pretty much the only thing that these commercial propagators are doing across the pond. By the way, incidentally, I didn't mention this earlier, there are nurseries up in Canada that are producing somewhere in the neighborhood of 40 million grafted transplants a year for the hydroponic greenhouse industry. And again, they're all using the tube grafting technique as well. Now, the thing that's nice about the tube grafting technique is, one, it's very simple. As compared to the cleft technique where you're like carving a turkey on the stem, this thing you basically just put one quick cut, stick the clip on, stick the scion in, and you're done. The other thing is that it's done when the plants are really small, which makes it a high throughput system. You have less time that you need twice as much bench space. You have smaller healing chambers to fit more plants, and in general, it's just easier to manage the smaller plants. This diagram came from that extension publication I mentioned earlier, and I'm not going to go through all the details of it, but basically, generally speaking, we typically have to stagger the seeding of the rootstock and scion, because it's not always that the rootstock goes in first. It's not always that the scion goes in first. It really depends on what scion and what rootstock you're utilizing. But bear in mind that some of these rootstocks germinate at different speeds and grow at different speeds than the scions. And so what I really recommend you do, if you have a grower that's wanting to look into this, is tell them to take 15 to 20 seeds and do a quick test, about a month ahead of when you're planning to do it, to see how quickly these things come up and what the difference is in size when you actually get to the day of grafting, so that you know how many days you need to stagger them. I've had rootstocks that I have to plant almost a full week in advance of the scion. Now with Maxifort and Beaufort, those ones both come up pretty quick, so you don't have to worry about it so much. Maxifort, sometimes I'll actually plant a day later than my scion because it comes up so quickly. The plants are grafted when they're about 3.5 weeks old. We move them into a healing chamber where we pump up the humidity as much as possible, cut down the light for about 48 hours, and then we slowly begin reacclimating the plants by basically giving them a little bit more light and then a little less humidity. And then about 8 to 9 days post-grafting, they're ready to come out of that chamber and back into your greenhouse. Now, it is really important to have a week or 10 days after the chamber's done so that these things can harden off and sort of reacclimate to typical conditions. In general, it usually adds about a week to a week and a half to a usual production system. So if it takes you 6 weeks to produce a non-grafted plant, expect about 7.5 to 8 for a grafted one. Again, uniformity is key. And I already mentioned about the different rates of germination and period. But keep in mind that you really want that crop within the rootstock or within the scion itself to be uniform as well. And so, one of the things that we actually started doing a couple years ago was we started mixing sand into our substrate just to get the water to move through there a little faster. We found with undergrad waters in the greenhouse that, most of the time they miss a corner or a side or something. So we actually started lightening up the substrate and making them go in there twice a day. And then hopefully they miss certain spots. It's less likely over time. In terms of numbers, we actually have had very good success. We have had batches that have been catastrophes, of course. But in general, you should be able, once you get a system up and going, you should be able to have 90% success rate. We've had a lot of batches with 100% success rate. And it's really not hard once you get it going to maintain that level. We typically put our plants in these DPS 50 trays, the speedling trays, some people call them, the 50 cell trays. And I do that for two reasons. One, I actually like that they don't really give adequate space, and it actually forces the plant to stretch out a little bit, and it gives you a little bit more room to work on the stem. I used to use 606 deeps when I first started this, but I had nice, stocky, short plants, and then I wasn't able to work on that stem quite as well. The DPS ones will make them stretch out just a tiny bit more and just give you a little bit more room. The other thing that I found is you can take this 50 cell tray and cut it into strips, so you have basically a 2 by 10 strip. And when you're actually doing the grafting, that's really nice just to manage it. So what I'll do is I'll have a strip in front of me with 2 rows of 10. I'll basically chop, 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 clip, 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 scion, 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 and then I'll flip the whole thing around and do it again. If you're trying to reach into that tray of 50 plants, you're going to knock stuff around and cause a mess, and you're just going to hate life. You can also use a circular saw to cut these things in mass if you want to. So here's a plant that's about to be grafted. You can see it's relatively small, about 2 to 4 leaf stage. The clips actually come in 1.5 and 2 millimeter sizes, and so you want the stem to be a little bit bigger than that so it holds it nice and tight. We typically use a 2 millimeter clip, but I always have some 1.5s around just because every now and again you get a small batch, or maybe the smaller ones within a batch, I'll use them for that. Now, sometimes it does happen that a rootstock in a scion crop, even though I staggered the dates and everything, maybe the rootstock is getting too big, or maybe the scion is getting too big so that they're not going to match up properly. And so one of the things that I've learned to do is if you've got a set of plants that's getting away from you, move them into a cool house and get them to just slow down. If you can get them to stop growing for a couple days while the rootstock catches up or while the scion catches up, that's a really good way to manage that problem. But timing is really critical. These plants do not stay this size for very long in tomato, right? This is a fast-growing plant. And we just this spring, I was in North Carolina, and I was trying to train basically the new guy how to do this. And we had a problem because we walked into the greenhouse one day. It was like 3 o'clock on a Friday afternoon, and the plants were that size. I mean, they were perfect. They were ready to go. It was exactly what we wanted. But it was 3 o'clock in the afternoon on a Friday, right? And we're state employees, so we don't want to work too hard. And so I turned over to this guy, and I won't mention any names, and I said, well, it's 3 o'clock now. I said, I'll meet you here at 8 o'clock in the morning, and we'll graft these things. And he said, oh, I can't work on the weekend, da-da-da-da-da-da-da. I'm not going to do it. I just won't come in on the weekend. I said, okay. So we came back Monday, and guess what? These plants were all too big. And we had a nightmare of a time trying to get them to fit into those silicone clips. So again, timing is critical. Make sure your healing chamber is up a couple days prior to when you expect to graft, because they are growing so fast at that stage. So when you're getting ready for this, you really want to treat it like you are preparing for surgery. Make sure the plants are not water stressed or nutrient stressed. And this was mistake number one by this guy right here. My very first batch of grafted plants, I grown them in the greenhouse. They were looking good. The size was good. I had my clips. I walked into the greenhouse, and it was 3 o'clock in the afternoon or 2 o'clock in the afternoon. I'm like, okay, well, let's just give it a shot. And so I started grafting them. And at 2 o'clock in the afternoon, the plant is just transpiring at a tremendous rate, right? And so the minute you cut them, they start wilting. 60 seconds later. It takes no time at all for a plant under that kind of stress condition to begin to wilt. And so one of the things I learned early on was that if you do want to graft these plants, put them in a shade house, or better yet, in a head house, somewhere where they're not going to get direct sun for a couple hours before you actually do the grafting. And so that's what I do now. When I go in the morning, pull them into the head house, let them hang out there for a couple hours, and then do the grafting. The other thing that I've also done a lot of, and my wife doesn't always love this, but grafting at night is actually a great time to do this, because the plants aren't really under any water stress at all. Have a clean working area. Again, you're going to move these things into an environment where you could have a disease outbreak problem. Now, having said that, in all my years and many, many batches, and probably literally at least tens of thousands of grafted plants we've produced, I've never had a disease outbreak in my chamber. But you got to be super careful about this. You can be working with the plants a lot. If you smoke, make sure you wear gloves or wash your hands with milk. Anything you can do to disinfect your hands and your tools. Also, the grafting clips. Those grafting clips are actually reusable. And when they come, they should come clean, but you can actually collect them afterwards. And you can either use bleach to disinfect them, or we've actually cooked them in an autoclave in order to disinfect them. And I know, who's got an autoclave. But what this says to me is if you really are super vigilant about this, you could put them in a pressure canner and sterilize them that way, right? So the one thing I would be careful about with the bleach is just make sure you've rinsed them really good. I always tell the undergrads, rinse them 5 times after you've gotten what you think is all the bleach out of it, because you don't want that bleach in such close contact to that tissue. Again, carry out the grafting indoors. We talked about that. And just have that healing chamber ready to go. Make sure it's up and running. Your humidity levels are where they're supposed to be before you graft a single plant. Okay, so here comes the exciting part. Here you can basically see we basically just grab the rootstock and cut it. The angle of the cut, I get a lot of questions about this. We typically say somewhere between a 30 and 45 degree angle. The truth of the matter is I've never gotten a protractor out and measured the angle of my cut, okay? It just, I don't work like that. What's really important about this is the angles of the cut need to be consistent between the rootstock and the scion. If you've got one that's cut at a 30 degree angle and one at a 45, then when they come together in that clip, you're going to have this big gap on one side of the stem. So you want to make sure they're nice and consistent so that they line up really well and you get good contact between the rootstock and the scion stem. That clip, that silicone clip, it basically just slides right over the top of that thing. And you can see you can't actually squeeze them to sort of open them, but you really don't need to do that. They'll open on their own as you slide them right over top of the rootstock. And then you basically just insert the scion in there. And again, you can't see it very well because of the light. But if we were to get out a protractor, you would see this is a really nice, consistent, even, similar cut on the rootstock and scion. The other thing I would say to this in the same area is that if you know somebody that wants to get into this and they're just trying to sort of practice, tell them to do some self-grafting. And we've actually done a bunch of this for our experiments for other reasons, but basically it's when you graft a plant back onto its own root system. And the reason why this really helps you learn the technique is because when you self-graft, you put that, there's no way that angle's not going to be consistent and the same, right? They should match up perfectly when you put it right back in. And so what happens is the management part becomes more, can you manage the healing chamber and not can you do the grafting technique? You know what I mean? So if you have a batch of self-grafts and a batch of rootstock grafts and you put them into a healing chamber and all of them die, then that's a healing chamber problem. If you put them both into a healing chamber and only the rootstock grafts die, then maybe you need to work on the technique a little bit. So once the plants go into this chamber, basically what needs to happen is we need to provide time for the plant to heal itself. We call this thing a healing chamber, but it really doesn't do anything healing. Tomatoes are an amazing plant, and they will heal themselves if you give them time to do it. And basically what they have to do is produce this callus tissue and reconnect their plumbing tissues within the plant. So basically the purpose and the function of the healing chamber is really just to alter the physical environment so that that scion doesn't need a root system while it's healing, right? And this is the way we do this. We talked about transpiration earlier, but water loss in plants is basically driven by the difference in humidity between the outside air and within the leaf, right? And because it's much less humid in the air, it's basically pulling the water, and I'm oversimplifying now, but you're essentially pulling the water through the plant. So what the healing chamber does is it basically just causes a traffic jam. You raise the humidity way up, and then essentially it's not dehydrating the scion, right, through osmosis. And it's the same concept with rooting cuttings as well, right? Any kind of vegetative propagation. So basically what the purpose of the chamber is just to reduce that water stress on the scion, and then the plant will more or less heal itself. And so when I go into a healing chamber, or excuse me, when I go into a greenhouse and look in the healing chamber, one thing I really look to do is make sure those leaves are popped up and nice and turgid, particularly in the first couple days. So we're going to talk a little bit about the healing chambers here, and I'll show you some pictures. Again, we've had anything from super high-tech ones to not high-tech ones. This one is pretty high-tech, or at least it looks like it is. Basically the main thing you have to learn how to do is regulate humidity within this chamber. So for those first 4 or 5 days, you really want as high a humidity as possible, like above 90%. And I honestly have not put a lot of, what are they called, hygrometers into my healing chambers in order to manage this, but you should be able to see some vapor within that healing chamber when you open it up. And one of the best ways to do this, especially for small growers with small chambers, is to use these little cool mist vaporizers. It's really important that it's called a cool mist vaporizer, not a warm mist vaporizer, because you can turn your healing chamber into a sauna if you're not careful. If you want to scale it up a little bit, a hermetifier is basically the same thing, and you can buy these things for about $350. at most horticultural supply companies, but it's basically just a giant humidifier on steroids. You can also do this passively too. That picture I showed of Korea earlier, you notice there weren't any vaporizers in that system, right? They have enough soil and enough bench space that basically you're basically adding humidity passively in order to get the job done. And one of the best ways to do this that I've found is actually you can get these wallpaper trays used for wetting wallpaper, and they're about the same length as 2 trays of plants. And so I'll actually stick these wallpaper trays of water into my chamber, and that'll help passively increase humidity. Do not use a hose-in mister. This was a big mistake by Cary number 2. I did manage to graft some plants. I went and looked at the chamber the next morning. I was like, oh, maybe they need some humidity. And I had one of these little hose-in misters that we use typically for seedling containers. And I shot it in there, and I watched all of my scion go pop, 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 pop right out of the clips. Anything that puts physical force on that scion is going to pull it out of the clip. So do not use a hose-in mister. In terms of overhead watering, I do generally use some overhead watering, but I usually wait until the 3rd or 4th day after grafting, and this is something that I do. I've been doing this for a very long time. I've had millions of people working with us. I'm not afraid to let an undergrad try and do the slicing and dicing. I'm the guy that does the overhead watering. You have to be very careful about this. And here you can see a bunch of plants after they put into the chamber. This is probably about somewhere in the neighborhood of 700 plants. And you can actually see this was the last batch that was done. See how they're a little bit wiltier than the rest? These have probably been in the chamber for a good hour or 2. And so you can see how quickly they pop that turgor back up. This is about the smallest you can start with. And they're known as biodomes or something. I'm sure you guys have seen this. But we've actually had pretty good luck grafting, especially for a home gardener that's interested in this, or if you got a small grower that just wants to try a few plants. These tend to work fairly well. Step it up a notch here. This is one that I built in the greenhouse on campus. It's real simple. PVC frame. Basically have poly on the bottom, poly on the top. These are very technical. These are black plastic trash bags cut longitudinally and thrown over the tray, over the chamber. But the most important component here is actually my old camping tarp. And this is really doing more work than anything else on this chamber because it's keeping the direct sun off of the healing chamber. If you let any direct sun touch that healing chamber, you're going to get this double greenhouse effect, particularly if there's black plastic on it, and it will cook those plants. I mean, I've seen it happen. And generally, when we have a catastrophe, you can blame it on this problem right here. The hardest thing is trying to keep that chamber at the humidity levels you want, but without, again, turning into an oven. Here's another chamber. The only reason I wanted to show you this was just to show that you can actually double stack these things. Keep in mind the first few days they don't need much light, and so you can think vertically with your chamber. There's actually plants down here on the lower part as well as the upper part. And I've seen pictures of fellas from Holland where they actually build these huge pallet systems, and it's like a pallet with shelves and shelves and shelves. They fill it full of plants, they drape it with plastic, and they leave it in there for 48 hours. Here's one at a grower's farm, and again, this is very simple. This is rebar, cinder blocks. You can see the cool mist vaporizer. Again, this is weed fabric, in this case, keeping the sun out. This is the fellow from Pennsylvania, and you can see he's made a little bit more professional here. He's basically got wire hoops. He's actually on an ebb and flood bench, which is really nice. And then he's got multiple layers of shade cloth. Typically what I like to do is have 4 or 5 layers of shade cloth in the beginning, and then after that 48-hour period, just start shaving the layers off and basically take 1 layer off per day. If we go back to our picture from Korea, you can basically see the exact same thing. The clear poly, of course, to keep in the humidity, shade cloth to darken it inside that chamber, and then the most important part is that shade system above the greenhouse. Notice that whole greenhouse has one giant piece of shade cloth across it. And I would actually suspect if you could find a way to keep it clean, I could see a really nice system where you have plants underneath the bench and then you bring them up about 48 hours later, and I could see that being really useful for commercial production. After that, you put them in the greenhouse for about 7 to 10 days. The clip itself will actually fall off. These are silicone clips. They expand when the stem grows, and they just fall right off of the plant. Once you get them back onto the farm, there's a couple important things to mention. One, planting depth. Of course, keep in mind we're doing this to manage soil-borne diseases. If you put that susceptible scion tissue underneath the ground, you're then going to have disease. So although my dad taught me to plant tomatoes as deep as possible, keep in mind that with grafted ones, you really want that graft union above the soil line. The other thing is I usually recommend to try and get your first string on as quickly as possible just to get those things up off the ground. Occasionally we do see some suckers coming off the rootstocks. It's less of a problem if you graft it below the cotyledon leaf, but it's usually not a big problem in general if you're suckering the plants anyways, which most commercial growers do. And of course, this is what happens if you don't. This is a big old rootstock sucker come off a Cherokee purple tomato. And then again, I mentioned vigor before. You can see our Max Fort grafted plants on the right compared to our non-grafted ones on the left. You know, it's important to be ready for this kind of vigor because you don't want your whole stake and weave system falling over and crashing down. Think about the ways you're going to hoist that plant up, your plant spacing, your fertility, in order to manage that vigor. And here's the ways that we've done it. I mentioned the twin leader system before. Steve up in Pennsylvania, we also did sort of a modified twin leader for stake and weave, where he basically just pinched those plants and let them grow the 2 suckers out. But then we did not pinch any suckers after that. So it basically just sort of forced the plant to just widen out on that row. It was most useful for that 36-inch spacing. Other than that, we decided we probably wouldn't do it anymore. So that's pretty much it. I'm not going to read through this stuff. I don't know if there's any time for questions or not, but I'd be happy to hang around afterwards and answer questions out in the hallway.
There's probably not time for questions right now so that we can get Mike in, but Cary will be here for a little bit to take questions from each